So this is question 4 on your problem set 2 part 2. And for those of you who had to leave at 10:50, I'm just recording this so you have an idea of how to do this problem. So the question here discusses the gestational time of 4 moms. So there are 4 moms, so the sample size is 4, and the gestational time for the first birth and the second birth are recorded. It's the same mom, and we're getting 2 numbers from the same mom, so that is the first and the second. So this makes it a matched pair problem. It's not 2 independent samples, it's matched pair. Okay, so when it's matched pair, we have to create a third row or column depending on how it is, and that would be the difference between the gestational times. So we're going to go consistently first birth minus second birth. Okay, we are assuming that the second birth is lower. Just to get a positive number, I'm going first minus second, or I could go second minus first. Okay, it doesn't matter. So let's go first minus second. I take the difference between these 2 numbers, these two, and these two, and I get 2062. So this is the first step to a matched pair problem. I need to take the difference in the gestational times. The mean is 2.5 and the standard deviation is 2.52. Now, where do I get these numbers from? I need to use the calculator function. Make sure you know how to use your calculators. If you don't know how to use your calculators, just let me know. I might be able to send you some links from YouTube. But I think you should know this right now. You should know how to enter numbers into your calculator and find x bar and s subscript x automatically. Do not use formulas to figure this out. Okay, once this is done, so we're doing the solve part. So the first step would be state. In the statement, we say we will find evidence that there is a difference in the gestational time of the first and second births to the same parents. And basically, I get the words from the question. Formulate is, here we are not estimating the mean, we are trying to prove something, so therefore it would be a hypothesis test. Since the same mom is used for both the numbers, right? The first and second birth gestational times. It's the same mom that is giving us 2 sets of data. So it's a matched pair problem. In a matched pair problem, we take the difference between the gestational times, and that gives us a new variable x. So we use a single sample. This becomes a single sample t procedure because we've created this variable. We do not know what sigma is, so it would have to be a t procedure. And the formula is t equals x bar minus mu o divided by s over radical n. So in the solve part, we first write down our null and alternative hypothesis exactly the way it is written here, right? And that is mu equals 0, mu, and the question says, is there a difference in the gestational time? They're not talking about less than or greater than, they're talking about a difference. So therefore, this is a 2-tailed test because of the not equal to, or a 2-sided test. Either way is correct. Now t is equal to x bar, which I get from my calculator, minus mu o is always 0 for a matched pair problem, divided by s, which is the sample standard deviation again that I get from my calculator, divided by radical n, which is 4. So this is equal to roughly 1.98. And use this. We go to table C. And table C, notice this is degrees of freedom 3 because we're looking at all this stuff here. Degrees of freedom 3 because the sample size is 4. We are looking for the number 1.98, which lies between 1.638 and 2.353. We go down the column and look for the two-sided numbers. And that is 0.20 and 0.10 for the two-sided test. So now switching back, we write down the p-value. So write down your t equals 1.98 and write down the two numbers between which your t-value lies. And that is 1.638 and 2.353. 1.638 and when we go down the column, the p-value lies between 0.10 and 0.20. Always put your smaller number on the left, larger number on the right. And our alpha, we are comparing it to 5% level. So that is 0.05. Obviously, the lowest that the p-value is 0.10, which is greater than. So p-value is definitely greater than 0.05. So we fail to reject. So what is our conclusion? So we conclude we do not have evidence. And the minute you say the word evidence, 0.10 less than p-value less than 0.20, to prove that the gestational time, the difference in the gestational time, what we are trying to prove here, that there is no difference. We do not have enough evidence to prove that there is a difference in the gestational time of the first birth and the second birth. Just fill in the blanks based on the question.